Okay, question 3. We have this function f(x) equals negative absolute value of x on an interval -5 to 8. So it's important to know that the function has a corner at x equals 0, right? Because the graph is positive on the x-axis on -5, -4, -3, -2, -1, and then 0, and then all of a sudden it changes direction from having a negative slope to a positive slope. 0, 1, 2, 3, 4, 5, 6, 7, 8, and that's positive again on the y. That's positive on the y-axis, I should say. Okay, so it's got that corner, and that's what they're asking us to do. Break it up into a piecewise function based on that corner. When f of x is on the interval -5 to 0, the graph of the absolute value of x is going down. Right? This is what they're talking about right here. That's the graph of y equals -x, right? It's got a -1 for a slope. So they want us to say that this is -x. And so since it's not just the absolute value, but it's the negative of the absolute value, that's why they have the extra negative sign on the outside, and that gives us a positive x. And then what's happening on the positive side, for a regular absolute value of x, it's positive when x is greater than 0. So we got a positive x, which is the same thing as negative x. I guess that's all they're looking for there. To find the local maximum minimum, we must find the critical points. Critical point is the number in the domain such that the derivative equals 0 or the derivative does not exist. So if you try to take a derivative of both these, set them equal to 0, you're going to solve and you're going to get x equals 0 as a critical point. The interval -5 to 0, f(x) equals x. So the derivative is 1, and the derivative up here is -1. Both these derivatives exist and are never equal to 0. The derivatives are never equal to 0. It's always 1 or -1. Therefore, what's going on here? Critical points. Oh, okay, so it's saying parentheses. So we're not including x equals 0. They're never equal to 0. On this interval from -5 to 0, if we exclude 0, the derivative is never equal to 0. The derivative is either a positive 1 or -1. It's never equal to 0. So there are no critical points on those intervals. Consider the derivative by looking at the limit as x approaches 0 of the derivative. Okay, so for a derivative, I don't know, there's a whole bunch of symbols here, but the derivative approaching 0 from the left has to be the same as the derivative as you approach 0 from the right, and they're not, right? So the derivative fails to exist at x equals 0. The limit as x approaches 0 of f(x) does not exist. And x equals 0 is a critical point because the derivative fails to exist. Is there a local min or a local max? It's a local max for this, right? Because the graph of the negative of the absolute value looks like this. Local maximum itself is the function value at x equals 0. So if you plug in 0 into that function, you get out 0. Negative absolute value of 0 is 0. The coordinates where this occurs at 0, 0. I don't know what there. I get parentheses. So 0, 0. They just take forever, don't they? Lots of clicking. Absolute maximum occurs if the x value of that maximum is greater than all the other possible x values on some interval. And a minimum occurs when the value is less than f of x. So some x equals 2 maybe. That's greater than all the other possible ones on that interval. Or less than if it's a minimum. Oh, technically it should be, greater than or equal to, less than or equal to. And then absolute extreme. Oh boy, what are we doing now? F of 0. Now if you plug in 0, you get out 0. There's an absolute maximum of x equals 0. Coordinates of that maximum. I feel like this is deja vu. We already found that out. Hopefully you're on the last part. Summarize all local and absolute extrema. I mean, the graph we already just looked at. It's from -5 to 8. There should be a closed dot on -5. So x equals -5 to 8. This was the one that has a closed dot. Absolute maximum is 0, 0. We said the absolute minimum, if you look in this graph, we never actually reach the absolute minimum. We get infinitely close, but we never reach it at x equals 8. So that's 8, -8. Actually, it might be D and E. Let me think about that. I don't think there is an absolute minimum because you never quite reach -8. You get infinitely close, but you never reach it. A local maximum would be highest value on some sort of interval, some sort of equal interval around it. It only has a local maximum, does not have a local minimum other than the endpoint. Okay, that's it.